first of those is the following. Whenever you have to differentiate with respect to x, a function fx which has been integrated with respect to x, that is, you get d by dx of integration of fx with respect to x, the result is the original function itself. In fact, this is a crude form of the statement of the fundamental theorem of calculus, which says that when a function which is getting integrated with respect to x, then it is differentiated with respect to x, you get back the original function fx. Right? Differentiation of an integral is the integrand itself, or in other words, differentiation and integration are inverse operations. So this result can be used many times in your objective exams in order to do some integration questions. So if you get a question on indefinite integration where there are no limits to integration, then you can just differentiate all the 4 options and see which of the differentiations will lead you back to your original integrand. So this provides sometimes, not always, a shortcut method to do your integration questions in the exam. You don't have to think about the various ways in which the correct integration or the correct substitution might be so that you get the correct answer. You can just reverse engineer your way back to the question from the solutions. We'll discuss more on this when we are doing actual examples. We'll move on to the next rule. Integration of k times fx with respect to x is equal to k into integration of fx with respect to x, where k is a constant. That is, integral of the product of a constant and a function. Second rule, integration of k times fx dx equals to k times integration of fx with respect to x, where k is a constant. So the integral of the product of a constant and a function equals the constant times the integral of the function. That is, in words, well, how do we do it practically? Integration of 5 times of, say, the function is sine x will be equal to 5 times integration of sine x with respect to x, and so you get negative 5 cos x plus c. So this is the way you deal with a constant which is multiplied by the function to be integrated. Okay, next, integration of the sum or the difference of 2 functions is equal to the sum or the difference of the integrals of the individual functions involved. So this rule does not apply just for 2 functions, it applies to any number of functions which have a plus or minus sign separating them. Right? The integral of the sum or difference of a finite number of functions is equal to the sum or difference of the integrals of the various functions. Right? So again, the equation describes it much better than the actual sentence. So for example, if we have to integrate x plus log x minus e to the power of x, this becomes integration of x with respect to x plus integration of log x with respect to x minus integration of e to the power of x with respect to x plus the constant of integration. Okay, next. So the above 2-3 results, which can be generalized, they can all be combined together into this one big property. Integration of k1 f1 x plus k2 f2 x plus or minus k3 f3 x and so on up to kn fn x will be equal to k1 into integration of f1 x with respect to x plus or minus whatever the actual value is in the actual problem, k2 times integration of f2x with respect to x and so on right up to kn integration of fn with respect to x. Integration of the linear combination of a finite number of functions is equal to the linear combination of their integrals. So these are all the rules that you have to look at while doing integration questions. You would be wondering, where is the product rule and the quotient rule the way we had it in differentiation? Well, there is no such rule as far as integration is concerned. Integration does have something equivalent to a product rule, but it is not exactly a product rule in the sense that it does not apply in general to 2 or 3 functions multiplied. It applies only to 2 functions which are multiplied by each other, and that too in very specific cases. That is why you cannot do integration of any random function that is thrown at you, like you can do differentiation. In it is possible to differentiate any complicated function that's given to you, but the same cannot be said of integration. So many times integration questions are not done by actual mathematicians. They just program it into a computer and find numerical answers to their values.